Okay, so what is a hive and what is the difference between the hive and RDMS, and what is the difference between the hive and MapReduce and Page, and what is the hive architecture and what is the hive metastore, and what is the internal table and external table in hive. Okay, so first of all we try to understand like what is the hive. So hive is kind of SQL tool. Hive is SQL tool and which is developed by the Facebook. It's developed by Facebook. Okay, and then later it is donated to Apache. Okay, so now it is a Apache Hadoop ecosystem tool. Okay, and it is data analytics tool. So whenever we do any analytics in big data, so we have a different analytics tool in big data is Hadoop ecosystem component. So one is we have MapReduce, Page, and Hive. These are the three in Hadoop ecosystem, and another one is Spark is there. So Spark is for batch processing and real-time processing. Okay, but these three are only for batch processing. These are batch processing. Okay, so what is the difference between the batch processing and real-time processing? So batch processing basically when we are going to analytics data, analyze the data, that should be the historical data. The data is already present, and we are going to analyze the data. So that is OLAP data. We can call it OLAP, online analytical processing. So that is OLAP. And when we are saying Spark is having a support of batch as well as real time. So batch like historical data, batch means historical data, and real time is streaming data. The data is coming on the fly. Streaming data and data is coming on the fly. So some examples like where the streaming data. So we can say like credit card swiping data, right? When we are doing any payment transaction using the payment gateway, so the data which is generated, payment data, so that kind of data is streaming data. Or we can say some log files are generated. So log files are like when we are navigating any website. Suppose I'm going to some options in the website, and then that data is generated. The log data we can use as a streaming data. So these kind of data are the real-time data. So it's not exactly real-time, but we can say near real-time. Okay. So that kind of data, if I want to process, so we can use Spark streaming. Okay, and so these are basically the background of what are the analytics tools are there. So Hive is SQL data warehouse tool. So Hive is SQL data warehouse tool. So we can write exactly the similar kind of queries like we write in the RDMS database. So I will tell what is the difference between the Hive and RDMS. Okay, so if I compare Hive and RDMS, so I will say Hive is having schema on read. Okay, schema on read, but RDMS is schema on write. So what is the difference between the schema on read and schema on write? So first of all, what is a schema? Right? We already know about the schema is like now we are defining the data types, right? We are defining the fields and fields having the data types, and we are representing fields with data type using the schema. And we know right in Hive, in RDMS, the schema, when we are writing the data, when we are inserting the data, it is checking the data types. Okay, that is the reason RDMS is a schema on write. Okay, but Hadoop, but Hive is schema on read. So it is not restricting. Suppose I am creating a database in Hive, and then I am creating a table in Hive, and then I am writing the data, into Hive table. So I will not get any issue. I will not get any problem. Even some data types are wrong, I will not get any issue. It will insert a null. I will not get any issue. But when I'm just doing the select command, doing select from the table, then it will give the error. Okay, so basically it is not giving any issue while writing the data. So that is the reason when we are writing the data in hive table, it is more faster. So writing data in hive table is very much fast. Okay, because it is not doing any validation, it is not checking anything. Very much faster. Okay, as compared to RDBs. So this is the main difference. What is the schema on read and what is the schema on write? And Hive is having the SQL command support, same like RDMS. And Hive is working in the distributed environment. So Hive is basically on the platform of Hadoop we are using, right? So basically Hive is using SDFSs as its storage. SDFS is its storage. But RDMS is using file system as a storage. RDMS is using file system, any file system where we have installed Oracle, MySQL, SQL Server. So that file system it will be using. The file system is a storage. Okay. So here in Hive, what are the advantages over the RDMS? So I can say Hive, I can read the different types of format of the data. I can read different types of format of data. So such examples like CSV file, JSON file, XML file, and we have different other types of format. Avro is there. I will tell about the Avro. Avro is a serialization, deserialization file format. And we have Parquet file format. It is columnar file format. So this is these file formats, Avro, Parquet, these are the compressed file format. And these file formats, Avro is a row-oriented file format. So they have its own pros and cons. Like some places the Avro is very good fit, but some places Parquet is good fit. So sometimes if I need to read specific columns of data, I will go for Parquet. So in that case, I will not use Avro. But sometimes I have to serialize and deserialize the data. I need to send the data over the network. So the Avro is a good fit. And some other advantages are there. I will let you know. I will tell those advantages. What are the advantages in different file formats? So here I'm going to just tell about what are the different types of file format is supported in Hive, and we can use those file formats. Okay. And there is a ORC file format is there that is called optimized row column. So optimized row column. So this is the default file format in Hive table. Okay. So basically it is giving a more file read and write support it is giving. Like more like we can read the data from file to Hive table, and we can read the data from Hive table to generate the files. So it is giving the advantage of reading and writing Hive tables. Okay. So basically, other things like if I say what is the difference between the Hive and other analytics tools. So if I talk about Hive and MapReduce and Pig, so all are Hadoop ecosystem tools. So these all are Hadoop ecosystem tools. So basically, MapReduce we know it is Java-based tool. MapReduce is a Java-based framework, and it is using map function and reduce function. Okay. So everything is generated on the behind MapReduce only. Whether we are writing a pig script, whether we are writing a Hive queries, it is generating behind is a MapReduce job. Okay, but when we are writing our own MapReduce, so we will be writing our own MapReduce code. So we need to write like more lines of code we have to write. So sometimes if I'm writing one word count program. So I need to write approximate 200 of line of code. Okay. So same code same word count program if I write, if I write the same word count program in pig, so it will be 4 lines of code. Okay, and when I'm writing the same word count program in hive, it will be 1 line of code. So 1 line of code means select from star from table, like this. So this way, like hive is having more productivity. So when we are having only select operations, like when we are reading the data only, so the hive is better choice. But sometimes if I want to do some conversion, like some manipulation things I want to do on the data, some transformation things I want to do on the data, so MapReduce and pig is useful. Okay. So pig is now outdated, but nobody is asking about the pig because mostly things is done like the select query we write in hive, and the data transformation things also we can do hive, but we need to write data from one table to another table. So when we are selecting the data from one table and then I'm writing insert into the another table. So that way I can do the transformation. And hive is having the UDF also. Hive is having UDF. So UDF is user defined function. So we know, right, some built-in function is there, user defined function. So some built-in function is already present in hive. Same like RDMS is having the built-in function. So some built-in functions like date functions are there, string functions are there. So this way, the hive is having also built-in function, but it is having another support is there. We can write our own custom UDF, right? User-defined function. User-defined function we can write. UDF we can write. User-defined function in hive. So we need to write some Java class. Java class we need to write, and there we have to write a code for UDF. Okay. So it is the only Java part in the hive. This is the only Java part. So just we have to write a very basic single class we have to write, and then we have to create a jar of this project, and then we have to write one temporary function, and give the function name to this UDF. And this function I will use in my select command. So I will use select, the temporary function name I will use it in my select from table. So like this way we can use the UDF. So I will show how to create UDF, but that will be coming later. Okay, but first of all I want to tell about like what is the differences between the hive and MapReduce, and the hive and RDMS, and what is the purpose of the hive. So first of all, we need to understand like what we can do with the hive. So hive is having partitioning concept. Okay, high level I am telling first what we can do in hive. So hive is having a partitioning. Suppose if I say I have a one table and millions of records are there. If I am reading this table, I need to scan the whole table. Right? So basically I am going to tell here why we need the partitioning here. In our databases, in RDMS databases, we have partitioning concept is there. So partitioning is basically dividing the data. Based on the column value, we will be aggregating the data. Like similar kind of values in the column, will keep it in a one partition. Okay. So suppose if I want to read a specific column value data in table. So all those records, I will keep it in one partition. Table. So when I write a select query, I will write select star from table, where partition column I will say and specify the value. So what this will do, rather than scanning the whole table, it will scan only, it will read directly the data from this partition. Okay, so this is kind of logical division of the data. We are dividing into the partitions, and partition is giving the faster way of reading the data. So what we are getting the point from the partitioning, So performance is improving. Performance of reading data from hive table is improving. So like sometimes the question comes like, what are the ways are there to improve the performance, right, in hive? So that is the one way we can say we have partitioning, and how many types of partitioning are there? Static partition and dynamic partition. So I will tell in the detail how to create a partition, how to create static partitioning, how to create dynamic partitioning, okay, how to do bucketing, okay, so those comes around, okay.
Excuse me, can I ask a question here?
Yes, sure.
Here, we're talking about partitioning. So what's the difference between partitioning and indexing, basically?
Okay, so this is a good question. So indexing is basically, that is also a way of reading the data faster, right? We know we create indexes, right? So some of the primary indexes there, some composite index, and sometimes we create like our own specific column index we create, right? So the index is like basically we are not specifying any particular value, right, in the column. I want to read the data. So suppose if I say indexes, if I'm talking about, so I will be reading the data based on the column name, right? So suppose I say I have one employee ID is, that is a primary key, so by default index will be there, right? So that is one like auto index is there, right? Primary key column index, okay? But suppose if I want to create a specific column, I want to create as an index, right? So what I need to do, I have to create the unique index, right? I have to select a column and then specify. So what is the difference you will find here in the indexes and the partitioning? Indexing we are doing based on the column, particular column. But in that, and then basically what it will be doing, suppose when I'm doing the select query and that column is coming, that indexing column is coming in my select query, so it will be specifically reading those columns data. It will not scan the whole table columns, right? Unnecessary. Got my point? And partitioning is basically in a particular column, I have a 10 values, 10 different values. Okay, if I take an example of, suppose I have a different states data I have. Okay, so I have California states, 10,000 records are there. I have Georgia state having 5,000 records are there. So like this, I have the data. Okay. So if I'm writing the select query with where clause, select star from table where state is California. So here you see this is a partition column, state is a partition column, and partition column value is California. So here there is no role of indexing because here row-wise data I'm fetching, right? Because I'm fetching the row-wise data, but it's on the some column value.
So basically, partitioning is kind of indexing within indexing. Is that correct?
Yeah, you can say it is automatically maintaining indexing within indexing, right? Basically, you right? Basically, column is there one index column, but in that particular index column, some specific rows I want to get it. So I'm using that partition column value. Okay. So here I'm giving the hard-coded value, right? This value, but this is called as static partitioning. But suppose in my table having 100 columns, 100 values are there like this, 50 states data is there. So do we need to write like this manually? We select where, so it will be automatically divide. So that way is a dynamic partition. So hive will automatically detect how many different column values are there, and then it will divide into the logical partitions automatically. But sometimes if I'm sure, like suppose if I'm doing partitioning on, right, so there is only two options, male or female. So I can go for static partition there. So sometimes they ask like, what is the difference between the static and dynamic partition, and then we should go for what kind of partitioning. So when we are sure, like these are the number of partitions are there based on the column values, so I can go for static partition because I need to load the data manually in case of static partition. okay, in the table, partition table. But in dynamic partition case, I'm giving a responsibility to the hive table. They will find how many partition values are there and it will distribute the data. Okay, I will give the complete clear example so it will be more clear, right? What is dynamic, what is static. Okay, and one more concept is the bucketing also there. So sometimes it is confusion what is the bucketing role is here. So partition is the concept of dividing data logically as column values. Okay, but bucketing is it's physically it is creating the files. Logic it's creating output file. Bucketing is creating output files within partitions. Without partition also we can do, but if I am doing partition with bucketing, so further first the logical division will come partition, and within partition the file will be there, like file number 1, file number 2, file number 3, another partition 2. So there again file number 1, file number 2, file number 3. So like this we are creating out. If I am not using bucketing, so only one partition, one file will be there. One partition, one file. Logically. Okay. But when I am just distributing the data in partition into number of files, so that concept is called bucketing. Okay. So bucketing is like basically one bucketing key will be there, distributed key, distributed by. So we have a one key that should be unique key, distributed key. So that will be distributed these output files. Okay. So far it's clear. Any doubt? Any other doubts? Anything? Mike?
Can you repeat the question? I'm sorry.
Okay. So the next thing is what is hive architecture and hive meta store. Okay. So hive is having the two things. So hive is having interface to show data in tabular form. Same like in the databases we have, right? Tabular form. And second part is storage part. So storage they are using SDFS, right, for storing the table's data in the files. Okay. So there the data is stored in files. Okay, but actual representation of the data is in tabular form, and that is basically row and columns. So rows we say record, same like in RDMS, and columns we call fields. Right. So same terminology is there, nothing different. So everything is same. So here is a little bit syntax is different, like we are giving the location of the file also, where the table is belonging. Okay. So there one concept will come, internal table and external table. So that I will tell. So where the internal table is created and where external table is created. Okay. So and the storage part will be the SDFS. Okay. So their actual data will be stored in SDFS. But interface will be showing. So what is matter store thing? So matter store is the information about the database, information about the hive table, information about hive table. So suppose if I am going to create a one hive table, EMP hive table, and this hive table is what kind of table it is, whether it's a managed table or external table. Managed means internal. So either we can call it managed or internal, it's same. So whether it's a managed table or external table, and how many columns are there, how many columns, column types. Okay, so all these information is stored in matter store. So one matter store DB is there, separate DB, matter store DB. So by default is Derby. Okay, so Derby is a very small database, Apache Derby, and that is come by default with Hive. We manually install and configure. Okay, but suppose I want to store some RDMS database as a matter store DB, matter store DB. I want to configure like MySQL, Oracle, or SQL Server. Any database I can configure with Hive as a matter store DB. I can configure it. but I need to do some configuration. This is custom configuration. This is called custom configuration. I need to do in hive site.xml. Okay, so Hive is having its own configuration file. Okay, so basically all Hadoop ecosystem components having their own configuration file. If I say MapReduce, so MapReduce is having MapRed site.xml. Site.xml. So like this configuration file is there. If I say Hive, Hive is having hive-site.xml. Okay. If I say HBase, so HBase is having HBase site.xml. So basically this is a one XML file where we do configuration for that particular tool. Okay. So in this hive site.xml, I have a database URL, username, password. So those things I need to configure. I need to change. Basically already there for Derby, but I need to change for my own database. Then that database will be used as a Metastore DB. So what is the use of this Metastore DB? It is containing the metadata. Like the information about the tables in Hive table. Okay, Hive database. So whether it's an internal table, external table. So there are the different types of Metastore. Like we can say one is the local Metastore is there, and one is embedded Metastore, and one is remote Metastore. So local Metastore, I will say Derby. That is coming by default. So this is an example of Derby database is a local. Embedded means like I am just using the same VM. I am just referring another database. So that is called embedded. Okay, and remote Metastore is like MySQL. So I am creating MySQL database in separate VM, like separate as a service. MySQL database as separate service or separate machine. So I will use with IP. In this hive-site.xml. Embedded means in the same VM, I am using MySQL or any other database I am using. That is called embedded. Okay. So these are the three different types of Metastore DBs are there: local Metastore, embedded Metastore, or remote Metastore. So mostly this is the by default is coming, but these two we can configure it based on our requirement. We can configure it for the different databases. Okay. So these are called Metastores. So next thing is what is the internal and external table. Okay. So this is very first concept as a practical concept in Hive table, in the Hive database. So internal table and external tables. So we know all like what is the tables, right? This is very basic concept. Like table is like we are containing the data in the form of row and columns. Okay. So why they divided into the two part, right? Internal table and external table. So internal table is, so Hive is having its own Hive is having its own warehouse directory is there. The location of the warehouse directory is Hadoop SDFS user Hive warehouse. So this is the internal table location. This is a by default location. So when I'm going to create any create table command, create table name I'm giving an EMP, and then I'm giving like this I'm creating a table. Sorry, string. Here is we have string, comma, name, age. So like this I create a table. So by default there is nothing I mentioned external keyword here. It is called internal table and it will go to this location. But external table, what is the advantage? External table I am specifying my own location in SDFS. Okay, suppose I say my location is test directory. So in this test directory, the file will be stored, which is referring to this EMP table. But how to create external table? So I have to create external table EMP, same syntax, everything will be same, string, a, int, and one more thing will be coming here, location. Okay, location I will specify here, /test. So what it will do, whatever data is related to this table, it will be stored in this location. So one difference is, if I'm going to drop this internal table, if I'm dropping this internal table, so my data and schema both will be deleted. Okay, so that is a disadvantage of the internal table. But internal table is having the security because it is in the warehouse directory. It is not external. Okay, so data and schema both will be deleted. But in case of external table, if I am going to drop the table, if I use drop table name, if I give like this, so only schema will be deleted. Schema will be deleted. So I have data will remain there. I can create again the table. So basically, anytime if I drop the table, only schema will be deleted. Data will not be deleted. But one benefit is there for the external table is, suppose this external table on this location, right? So I can create a multiple tables for this location. So suppose I have a requirement, here is only one table for one location. Okay, but for external table means this location I can refer to another table. Suppose I have another table name is EMP1. So I can create table EMP1 for the same location. So the benefit is here, I can manage multiple tables with the same location. Okay, so that is the benefit, like I can sync the data between these tables. Okay, so I can use the external table whenever I need to use multiple tables for the same location. I will go for the external table. But external table doesn't have security because any time like anyone can change the data or anything they can do. Okay, but this warehouse directory is secure directory, right? So that is inside the user hive warehouse directory. Okay, so I will show you how to create internal table, how to create external tables. If you drop the table, how it will behave. So we will see like how to create different types of tables. This concept is clear. Internal table and external table.
Yes.
Okay. Okay, and one thing I will share this one VM is there. This is Ubuntu VM. Okay, I will share to you my. This one is one VM. So you have to download it, and in VirtualBox you need to import. So simply you just import appliances. I will give the steps also. So once you import that VM, so you will get like this machine. So you will get the machine like this, Ubuntu machine. And this Ubuntu machine, so there is a username is data making and password is a data making. I will send it. So once you log in, so we can start terminal here directly. We can create a new terminal, and this new terminal we can start the Hadoop services. So already my Hadoop services are running. Okay, so if you see name node, data node, okay, so you have to go through the concept like this data node, secondary name node, I have already covered. So name node, node manager, resource manager, these are the storage services and computing services, right? So secondary name node is a storage service, okay. So first we need to start Hadoop. So when you enter this machine, when you enter in this VM, so first what you have to do is start -all.sh. So it will start your all Hadoop services. And next thing what you need to do, you have to start the hive. So what you need to simply do, okay, I just start hive again. So once your Hadoop services are running, simply type hive. If you type hive, so it will give you one hive prompt. Okay, so that is called interactive shell. So interactive shell means whenever you write any SQL command, so it will give you immediately the output. Okay. So one hive shell will come. Okay, so this hive shell, I think this command will not work. This is not clear. So if I want to run any Hadoop command, SDFS command, okay, I can run in the hive shell also. So there we need to use exclamation Hadoop fs minus ls slash. So and semicolon. So I can use all the Hadoop commands by using the exclamation. Otherwise, I need to start another terminal if I want to run any Hadoop command. Okay, so you can see here, you are able to see the directories listing, you are able to see. This is the root directory. So if I want to see a particular directory listing, so you need to write that particular directory. So this is the way how to write, how to use the hive shell for Hadoop SDFS command. Okay, so the main use of the hive is like we are going to create a database. Okay, if I want to see the all databases, there is a command show databases. The same command is there in the RDMS. So it is showing the databases. So default is a default database is comes by default. Okay, we don't need to create manually. So other databases I have created manually. The data making DB, EMP. If I want to create my own new database, so I can create database and database name test DB semicolon. So database is created. Now I want to just use the database, use test DB. Then if I want to create a table, so I have some create table command syntax, I will use it. I will share the zip. It is having all the commands are there, right? Different chapter by chapter. I will share the books as well as I will share this scripts also. Okay, so suppose I have a one create table employee I want to create. Okay, I will explain it. First I create a table. So table is created. So in this table creation, it is what kind of table it is? It is internal table or external table? It is internal table, right? I haven't used any external keyword here. So this table will go to the warehouse directory. So if I want to see where this table is, so Hadoop fs minus ls slash user slash hive slash warehouse, and one folder will be created with the DB name. So test db.db like this. So test db is a DB name and .db is extension. Okay, so one folder will be created with the DB name. So in this folder, one table folder is created. This is also table. So this is D, right? So D means directory. So this is again a directory. Okay. So if I go to this one slash employee, but right now I have not inserted any data in the table. So table is empty. So nothing is there. So if I do select star from employee, so there is no data. I need to insert the data. So if you see here in this command, I am using table name, and after that I have specified the column names. So this is a one column name and this is a data type. So hive is having the two types of data type. One is primitive data type and one is a complex data type. So primitive data type says like number, integer, double, those are the primitive data type. But some of the data types are the complex data type. So array is there, one is a struct and one is a map. So array means like when I have a same type of data is there, I will use array. But array is of what type? Some primitive type. So I'm saying workplace. So there are different workplaces there, like New York is there, and different cities are there. So those are the workplace. So I'm using array. Okay. But suppose I have another data type is complex data type is map. So suppose I want to store skill with score. So skill is my string type, but score is the int type. So here I am using a map type of data type. But sometimes if I am doing complex data type as struct. So here you can see two different data types are there. One is string type and one is integer type. So what is the difference between the array and struct? Array is storing the same type of data type, same type of value, but struct is storing the different data types of values. So here are the combination of the two different data types, gender and age. So this is called struct. Okay. So when we are writing a select query, so we will be using the dot operator. Okay, indexes like square bracket we will use to read the indexes. Okay, I will show you how to use this complex data type. So just I created a table, and here I am specifying here row format delimited, field terminated by pi. Even I can use comma also. So if my file is having the data, that will be storing with the separated by the pi. So all fields data in the file will be terminated by the pi. So if I want to give here comma, so my data will be separated by the comma. Collection items are terminated by comma. So like array collection data will be terminated by comma. And map keys data will be terminated by colon. So suppose I have a skill colon score. So I will use colon there. Okay. And finally, this is the type I am saying which type of file I want to store. Whether it's a text file data, whether it's a ORC file data, whether it's a Avro. So I need to specify store as text file. So text file means it's a plain text file, human readable file. That is text file. But I can specify here store as Avro, store as ORC, Parquet. So different file format I can use. Okay, I will tell more in detail what are the different types of file format and how to use it. Okay. So basically this table is empty table now, but we need to load the data in this table. So hive we generally don't write the data line by line. Hive doesn't support the data to insert line by line. So we load the data from the some file to table. Okay. So some file will be there, and that file will be having the data, and data we will be writing into the table. So there is a load command is there. Okay. So I can write this syntax, then it will load the data from some location to the hive table. Okay. So basically I need to create this text file. Okay. And then I need to use the select command. Like I want to do select star from table. If I want to get all the workplaces, I will do select workplace from the employee. But specific rows workplace I want, like workplace of 0, workplace of 1. Okay, so suppose array is having two values. So I need to do 0 and 1. Suppose workplace having the three values in some particular row. So I need to do 0, 1 and 2. Okay, but some rows having only one workplace. So only one value will come, other will be coming null. Okay, like this data will come. Any doubt? I will tell about this complex data type separately. This all commands, how to load the data, everything. So just I have created table. So once the table is created, I can see the data, and then I can query the data on the table. Okay. So I can write different select queries, and I can write the complex data types I can define, and then I can write the queries. So actually I have not copied the files. So I will keep it ready tomorrow 5, and what I will be doing, I will be starting all these commands. And before that, the data as well as these SQL commands I will share to you. So simply what you need to do, you have to start the Hive shell, Hive terminal, and then you can start copy pasting the commands, and then you can practice. Okay. So these are simple select commands. So how much commands you can practice? So these are simple, like different select queries command. Like we can use case and when we can use nested query, inner queries with clause we can use everything. Whatever we can do in SQL, same thing we can do here. Okay, so here we can write simple Hive table. Even the joins we also can do. So different types of joins also supported. Inner join, equi join, and we have left outer, right outer, full outer, and we have cross join. So all those different kind of joins also we can do. Okay, we can work on those joins. So any questions, any doubt? So what I'm thinking tomorrow I will be, this is a very theoretical part, so mostly theoretical. So what I'm thinking is tomorrow I will be starting, first I will be loading the data, how to load the data into Hive table, and then how to write a SQL queries to read the data from the Hive table. Okay. So tomorrow internal table and external table practical will do first. Then we will do the select queries and complex data types. And next thing is there the surveys. So surveys is a concept in Hive that is serialization, deserialization, survey. Okay. So survey is a serialization, deserialization. So there are many types of surveys are there. JSON survey, XML survey, CSV survey. So survey is nothing but reading the different types of file format data. Okay, Avro, survey. So whatever types of format of data I was telling here, somewhere I was telling about the CSV file, XML file, JSON file. So all are the part of the survey. Okay, so we need to use some jars. Some of the surveys are default survey, so we don't need to use any additional external jar. But like JSON survey, we need to use external jar. But other surveys like CSV survey, those are the default surveys. So Avro survey, there is a Parquet survey, and regular expression survey, regex survey. Okay, like some log files data I want to read, so we use the logix regex survey. Okay. So that will be coming after the SQL queries. So one session we will be doing internal table, external tables, and select queries, complex data types. Then we'll come to next to the surveys. Okay, so one by one we'll be taking all the examples of one by one each survey. Okay. Okay. Any doubt, any question so far in the session? So I will share the recording. So and you can post in the group. Anybody has any doubt and questions? So that will be easy. Like anyone can give the answer, and like everyone will be aware of the what questions people are asking. It's fine. Any questions, doubt? It's good. Okay, we'll continue tomorrow, same time, 8 p.m. Yeah, thank you. Thanks a lot.
Thank you.
Thanks, bye.
Have a good night.
Yeah.